Today we are going to learn basic principle of non-equilibrium thermodynamics or system, and here are some principles. Very important principle. We should understand there are at least 7 principles, and these principles are very important, and this is quite important for MSc level also. And first postulate is written as the entropy is the function of volume, energy, and the number of substituents. So it can be written as S is equal to the function of E and I. This is the first postulate, and the second postulate is, as we know that the change in entropy is the differences between the entropy changes with surrounding and entropy production. That is, we can write ds is equal to des. Des mean it is the entropy changes with the surrounding, minus tis mean the entropy production during the phenomena. Number 3, production of entropy. Production of entropy is also the sum of product of generated flux J and the force X. You know that the flux may be heat, maybe concentration, or maybe energy, and if the flux is taken as a heat, and the force is taken as a temperature gradient. Due to the temperature gradient, the heat will flow from one side to another side, or force is one kind of a quantity which is used to pull the flux. Okay, the force push the flux or pull the flux. So mathematically we can write DIS, that is the entropy production, is equal to the product of J. J is the flux and X is the force. So I have written 4 instead of this 4 we should write F. 5 number, this 5 will be goes here and 4 will become here. Actually the 5 number is 4, but I did mistake here. So according to this 4 postulate, actually this is not a 5, it will be 4. As we know that the generated flux J is directly proportional to force X, so we can mathematically write J is directly proportional to X. And J, when you remove this proportionality sign, we will write a constant L, and this L is a proportionality constant called phenomenological coefficient. And after this, as in case of 5 number, for 2 set of flux J1 and J2 and 2 forces X1 and X2 respectively, we can get a linear phenomenological relation. We can write J1 is equal to L11 X1, or L12 X2, J2 L22 X2, L21 X1. In this relation, we can know one relation, or we should know one trick or methods. Okay, now you can see here this one and this one. These two quantities or these two values must be similar. Okay, here also 2. Okay, this 2 doesn't matter with this one. Okay, so this 2 it depends upon these values. If here is 1, you can write here 1. If here is 2, you can write here 2. If here is 3, you can write 3. If here is L, you can write L. Okay, so in this way you can make a linear equation. Now after that, in number 6, there are some we can verify the above this relation. Okay, this relation. Number 5, actually there is written 4, but it is a number 5. In this relation can be verified by this relation J1 and J2. Okay, if you calculate the ratio of J1 and J2, you can get a finite value, and J2 by J1 you can get a finite value X1 X2 X2 X1. If you are going to find out the value ratio of J1 and J2, in this condition you can write the value of X1 is equal to 0 and in j2 by j1 you have to put the value of x2 is equal to 0. In x1 x2 you have to put the value of j1 is equal to 0 and x2 j2 value is equal to 0. If you put the substitute that values, you will get the finite relation or finite value. Number 7. Now if the phenomenological coefficient, that means L, are made to be a symmetric matrix, okay, symmetric matrix, then this relation will be satisfied. Lik is equal to Lki, okay, this relation will be satisfied, so which is called reciprocal on-Schreiber relation of equation or reciprocal on-Schreiber equation. It's a very important.